Hey, it's Kley. Welcome to another video. Today, I am doing one final, hopefully, pass on my Dumble Overdrive Special home-built clone amplifier, and I want to take you along with. We have a couple of objectives with this update. I need to firm up and stiffen up the power supply. The voltage rating on my filter caps was a little bit low compared to the voltage it was actually seeing, so we're going to stiffen that up. And second, we're going to add relay switching. This is my first adventure into relay switching. We're going to do a pretty deep dive into relay switching. Hopefully that can be applicable to you. So if you're interested in that, why don't you go ahead and dive in. Wanted to make a couple updates to my power supply. This is my first node of my filter cap, and as you can see, this is 20 microfarad at 450 volts. So right here, I've got my two rectifiers that go to this node, and then this filter cap was in this place. And I noticed I'm getting over 450 volts on that node. It's closer to 500, maybe 490 something, and so that's not going to cut it. Rather than stressing this guy past its limit of 450 volts, I'm going to use two of these. These are 150 microfarad, 400 volt capacitors, and if I run two of them in series with one another, that doubles the voltage rating, but then it halves the capacitance. So I'll actually have 800 volts of capacity at 75 microfarad, which will actually be better because it will also stiffen up the power supply. And I'm using two of these 220K resistors to spread the load across each one. And also, in order to do that, I needed to add this guy right here. This is another terminal strip, just because I was coming out of this point to ground, and I'm going to need another way to attach these guys because I did not have enough space. So we're going to run this first filter cap and dropping resistor over to this point, the second one to this point, and then it'll go to ground. Let's get rock and rolling. Alright, I have updated my power supply. This should be nice and beefy. Right here on this point, you can see my diodes are coming in. Then it runs along this yellow wire right here to this point. There's one 150 microfarad 400 volt cap with a 220K resistor bridging across it to this point, where you get a second 400 volt 150 microfarad cap with another 220K to this point, and this point is grounding down to here. And this also will bring the feel of the amp a little bit more closer to the original Dumble intent, with a high, we're going from 27 microfarads right here up to 75 microfarads with these two guys in series, because again, two capacitors in series, it doubles the voltage and it halves the capacitance. So 70 microfarads of capacitance with diode rectifiers is good, and that's going to create more of that very responsive pick attack, very quick, very immediate under the fingers. So I think that's going to be a nice update, and overall the power supply is looking really good. One more change in the same vein, you can see this capacitor here is 50 volts, 25 microfarad. That was located in this position right here where you see this black cylindrical capacitor. This is my negative DC supply line. So you can see this yellow wire right here supplies 50 volts from the power transformer. There's a little bit of a dropping resistor right there. That gray one, there's a diode right there that turns it, rectifies it, and then this is the filter cap right here. Now, that node in my review was pushing about 50 to 55 volts, so bumping up to 100 volt at 47 microfarad as opposed to this guy at 50 volts, 25 microfarad is just going to be a little bit beefier and a little bit safer. And actually, I did have trouble with this capacitor the first time around, if you recall some of my earlier videos. So I think we're, again, just kind of trying to future-proof this guy, make it rock solid, Today we are talking about relay switching in my Dumble amplifier. I'm going to explain how I implemented it, how I have wrapped my mind around it, and how you can implement it into any of your amplifier builds. So to get started, why do relay switching? Well, the really nice part about it is that it enables you to do some really easy foot switching without sending the audio signal to all the way down your audio cable. A relay switch is basically like, the version that I have is like a double pole, double throw switch, except on the inside it's energized, and there's kind of some magnetism, as I understand it, where when you introduce a current and a voltage, it actually magnetizes the switch to pull in one direction. Then when that electric current is disabled or interrupted, it allows the switch to flip back in the other direction. So basically what you're doing is, I've got a front panel, and I also have a 1/4-inch jack where I can plug a foot switch in, and that is enabling or disabling the ground connection for that voltage that's flowing through the relay. It's pretty exciting stuff. It's really sweet. Opens up tons of possibilities. First, I want to just show you the version that I've got here with my Dumble ODS style amplifier, what it kind of sounds like, how it's operating, and if I need to make any updates or tweaks. So this is literally the first time that I have experimented with it, so we'll dive into that together. Okay, I wanted to talk a little bit about how I implemented relay switching. First, I will leave a link in the description to where I got the parts. This is my relay setup right here. You can buy this from Hoffman Amplifier's website, and you can implement this into any amp build. You might have to make some adjustments to your setup, but anytime that you want to have switching of anything, whether it's any kind of double pole, double throw switch, single pole switch, channel switching, mid boost switching, any kind of switching that you can think of, you can use this pretty much to control it. It's really quite a nice setup. This was about $20 to $25, I believe, so it really isn't that terribly expensive either, which is really nice. So let's talk about how I implemented it. First, let's talk about the power supply. I'm using this line right here. These are my 2 yellow wires for my power transformer, providing 5 volts of AC. This typically would go to power the filaments in a tube rectifier. I'm using solid-state diodes, so I don't have that. So these are just unused free power lines. I believe this type of setup could also potentially work with your 6.3 volt filament winding. I chose not to do that though, because that kind of does some funky things with grounding. So anyways, we've got the 5 volts that goes in right here to the power supply board of the relay switch. That goes into this bridge rectifier that changes it from 5 volts AC to a little more than 5 volts DC. There's a large filter cap right here to smooth out that direct current. Because I'm using the 5 volt winding, I am not running into the next stage, which is actually the voltage regulator. It has this part right here, which I'm not using. This appears to be a L78050 voltage regulator. I believe this would be used if you're using the 6.3 volt filament winding. However, I'm not doing that, and I feel confident that my 5 volts here is going to be sufficiently stable to use with this. So I'm actually running from this, out of this filter cap, there's a hot wire and there's a ground wire. The hot wire runs over here to the relay. This is the relay board, okay? Now the relay does have a diode right here, and that helps to protect polarity backfiring to keep the switch safe. Then you've got right here, this is your 5 volt input, and then this lug right here is your ground, okay? So what happens is when the circuit is complete, meaning you have 5 volts in and you've got a ground connected, the relay switch is pulling in this direction. And then on either side, you have two single pole double throw switches, or in other words, a double pole double throw switch. And so the way I think about it, the middle lug is kind of potentially your input. Then when the voltage is applied, it kicks it to one side or the other. Now somebody may correct me if I'm wrong, but I believe that the normally open position is on this side, according to the switch. So then when that ground connection is interrupted, it kicks it back out to this other side. Either which way, what I've got is my signal is coming into the input jack. It's going into this first gain stage, goes through the tone stack and the tone switches, goes into the second gain stage. It comes over here to this. This is the coupling cap. That's the end of the clean channel, so to speak. That goes in to the relay. Then the relay either sends along this wire over here to the master volume input, which is basically into the phase inverter, the end of the preamp, right into the phase inverter, or it can switch on this blue wire right here to go into the overdrive tube. So again, input is on this first lug, and then when the switch happens, it goes either to this lug or to this lug. And right now I have this other side is left blank, but I could potentially choose to use that if I would so desire. So, all of that to say, this is a pretty neat little setup. I also have a foot switch jack, and I've got a switch here on the front panel, right? So remember the ground wire on this side? If this ground is connected, then the circuit is complete, and the switch will flip on and off. If you interrupt that ground connection, you flip the switch off. So this ground connection completing the circuit is what is causing the relay to flip. So I have a white wire going here to the switch, and then on one leg of the switch is open, no connection. The bottom leg of the switch goes to my preamp ground wire here. I also have sending out to this 1/4-inch jack to the tip, and then the sleeve is connected over here to ground. So my intention is I'm going to use a pedal foot switch like this in a pedal enclosure, and that will also give a path to turn the ground on or off. That's my intention at this time. Now, let's talk a little bit about troubleshooting. The switch seems to be performing really well. I was only able to test the amp on my direct setup. I wasn't able to listen to it in the room, but I didn't really notice that this had caused any weird noise problems. I am using a shielded cable. I've got a long run from here over here, so I'm using a shielded cable for that. I'm hopeful that that can help keep my noise floor down. I do have the output transformer wires over here running in somewhat close proximity to the relay switching, so I might kind of mess around with that a little bit to try to keep these wires tucked and out of the way. Maybe some of this kind of lead dressing might help. But so far, so good. Something I can experiment with a little bit more with. The only downside that I encountered is what I'm basically doing is I'm using the relay switch to flip on the input side. The signal is coming out of the preamp, and it either goes into the overdrive tube or it passes out to the master volume. I'm not switching it on the output side, meaning my master volume control technically has two signals. Right here, this is my master. It's receiving one signal from the relay switch. That's the clean path. It's also receiving a signal right here from this volume control. This is the master volume just for the drive channel. So there are two inputs here. And what that means is that these two volume controls are linked. So like even if I'm on the clean channel, what should be the master volume on the drive channel was still working. So I need to think of a way probably to use this unused open side of the relay to also turn off the output side of the drive channel so that that is no longer connected. I'm contemplating... I think what I'm contemplating doing is... I'm not sure. I need to think about that a little bit more. But so far, I'm actually quite pleased with how easy this was to implement. It was not terribly expensive. Hoffman has a really nice wiring diagram available. We'll also have links down in the description. I'll also have an image of my wiring diagram. But I hope you guys enjoyed this explanation of relay switching. I hope you enjoy implementing it into your amp. If you have any questions, please leave them down below. See you again soon. Thanks. Bye. Alright guys, that's going to do it. We're going to wrap it up there for this last installment of the Dumble ODS build. This is definitely going to go down as one of my favorite builds, just partly due to the nature of the amp, the complexity, and I learned a ton of things along the way, even though it's one of the... I've built plenty of amps before, but I still feel like I learned just as much on this one as I did on one of my first builds, and it just really was a ton of fun. And the final product I'm really pleased with. I think the amp turned out great. I think it's going to be a really superior amp. It can do just about any kind of tone you'd ever want. It's nice and quiet. It's a really nice, you know, probably about that 20 to 25 watt range with the dual 6v6s. And it just overall turned out really well. So I'm really pleased with it. I hope you guys enjoyed it as well. Hope you can take some things away too if you're looking to maybe add some relay switching or just curious about the Dumble thing. It was a really fun process overall. So let me know your thoughts down in the comment section below. Please check out some of my links if you wish to support the channel, and I'll see you guys again soon. Thanks, bye.